Here we're going to be looking at the idea of multiple zeros and their geometric meaning. Sometimes we have the same factors, but very different functions. For example, the function x minus 3 has an intercept at 3. The function x minus 3 squared also has an intercept at 3, or a solution at 3. And the graph x minus 3 to the 15th power has a 0 at 3, but these are three very different graphs. They occur with zeros of multiplicity. So let's define the multiplicity of a 0. If we have a linear factor, x minus c to the k power, and it appears more than 0 times, so it can be 1 time, 2 times, 3 times, so on, in a factorization of a polynomial, then c is a 0 of multiplicity. So all of these would be zeros of multiplicity. The 0 c of this multiplicity k has different behaviors depending on two things. If this exponent is equal to or greater than 1, and if the exponent is even or odd. We've talked about in previous videos the idea of being able to determine if the right side and the left side are going to go in the same direction of a graph. Well, this is coming into play here. Notice the difference. If I have something like x minus 1 cubed, we know from our previous discussions, because the leading coefficient is positive, the right hand's going to go up. And we know that because the exponent is odd, the left hand's going to go down. And now we know that there is a root at positive 1. So we can make that prediction. And it again, notice because it's odd, it crosses the x-axis. In contrast, if I have something like x plus 2 to the 4th power, it has 1 0 at negative 2, but it has multiplicity 4. And what you'll find is that graph flattens out. So how do we determine these properties of multiplicity? Well, if c is a real 0 of multiplicity k, then the graph will touch the x-axis at this point, c comma 0 on the x-intercept, and it's going to cross the x-axis if k is odd, and it's going to stay on the same side if k is even. Notice in this previous example, when k was odd, it crossed the axis. Here, it stayed on the same side. If k is greater than 1, the graph will flatten out. At this c comma 0. We can also get our graphs to be much more accurate using these ideas. For example, if we want to sketch the graph, f of x is equal to x plus 2, x plus 1 squared, and x minus 3 cubed. Note that the degree here is 6. And there is a positive leading coefficient. So we know this tells us the right side of the graph is going to go up. So as x goes to infinity, the graph is going to go up. As x goes up, y is going to go up. And because the degree is even, we also know that as x goes to negative infinity, f of x is still going to go to positive infinity. They're going to go in the same direction. Using the steps that we've previously discussed, we can find the y-intercept by plugging in 0 for x, which leaves us with 2 times 1 squared times negative 3 cubed, which leaves us with negative 54. So we know that the graph is going to cross the y-axis at 0, negative 54. And then we know that there are zeros at negative 2, negative 1, and positive 3. So we have zeros at negative 2, -1, and +3. Now, from what we've just studied, we know that because k here is 1, which means k is odd, we know it's going to cross the axis here. We know it's going to stay on the same side here, and k is odd here, so it's going to cross. So from all of this information, we can get a somewhat better picture of what our graph is going to look like using this idea of multiplicity of zeros.